In this investigation, we learned about the meaning of quantity. Whenever you are faced with a math problem, especially contextual situations, it's important to slow down and take time to identify the quantities in the situation. Quantities are attributes in the situation that can be measured, and identifying them is key to being able to accurately represent mathematical relationships. For example, when we imagine lighting a candle and letting it burn down, there are several quantities we can identify, including the following: the original length of the candle, the length of the candle remaining as the candle burns, and the length of the candle burned away. We can imagine each of these quantities being measured and taking on values. For example, at some moment in time, we can imagine taking a ruler and producing measurements for each quantity in a common unit, like inches. Some attributes of the situation don't really take on measurements. For example, the candle's scent, its color, and the city where it was manufactured are some examples of non-quantities. We can't represent these attributes with numerical measurements, and therefore we can't talk about the relationships using the tools of mathematics. There are additional examples of quantities in the candle burning situation that we haven't talked about yet. For example, the rate at which the candle burns is a quantity, as are the time elapsed since the candle started burning, and the total time it takes for the candle to completely burn out. When we know how to measure these quantities, we could talk about the relationship between these quantities as the candle burns. We will return to these quantities later in this course. In some situations, some quantities are fixed while other quantities are varying. The original candle length of 14 inches is a fixed quantity. The value never changes even as the candle burns away. The burned length of the candle varies as the candle burns, so the candle's burned length is a varying quantity. When a quantity varies, its varying measurements can be represented by using a variable. This is an important tool because the values of a varying quantity cannot be represented by a single number. We define a variable by choosing a letter to represent the quantity's varying values and by writing a specific description for the variable that includes providing our choice of letter, describing the attribute in detail, and defining a unit of measure. Without including all of these pieces, it won't be clear how to interpret the values in the situation. For example, suppose someone writes, "Let L represent the length," in the candle burning situation. What is wrong with this definition? First, we cannot interpret the meaning of a statement like L equals 4 because we don't know the unit of measure. Is this person representing a length of 4 inches? A length of 4 centimeters? 4 millimeters? Who knows? Second, there are multiple lengths in this context, so this person needs to be clear about which length he or she is representing. Does L represent the length remaining, the length burned away, or the length before the candle was lit? A much better definition is to say something like, "Let L represent the length of candle remaining in inches." This allows us to interpret L equals 4 as representing a moment when the remaining length of the candle is 4 inches.